today's episode of Future Says, we have Bill Magro, one of the world's most prominent voices in the HPC community. He currently serves as Chief Technologist of High Performance Computing at Google, and prior to joining there, only last year, he spent 20 years as Intel Fellow and Chief Technologist for HPC. Hello and welcome to Future Says, Bill. It's so good to have you on the show to talk about all things high performance computing and the cloud.
Thanks for having me, Sean. Glad to be here.
So it's undeniable that HPC has contributed positively to answering some of the world's most pressing questions and crises, to predicting and monitoring the spread of climate change, to the discovery of things like astrophysics and quantum chemistry, to doing the vastly distributed research that was so critical to the development and distribution of vaccinations over the past 18 months against COVID-19. However, traditionally it has been a technology available for the few, not the many. There are a lot of companies that would have loved to use HPC in the past, but haven't been able to because of the cost and resource constraints. Fortunately, with the invention of the cloud, all of this is changing. We're starting to do previously unthinkable use cases on premise, and we're starting to scale to a completely new set of use cases and users. It's never been a more exciting time for this convergence of the cloud with HPC, with artificial intelligence, and there's nobody better in the world than Dr. Bill Magro to tell us all about it. So Bill, I want to jump right into things. You started at Google 12 months ago. Prior to that, Google had never hired a chief technologist of HPC. So why did they decide that they needed to, and why was now the right time to do so?
It's hard to speak for Google what was going on. But one of the things that I observed is that when Google Cloud launched, it launched a little bit later than some of the other clouds, and the early efforts and focus that Google had around cloud was really around application modernization. So taking a lot of the things that Google had done that were really innovative and transformative and providing the same tools to organizations so that they could modernize their applications. So think in terms of cloud native applications and microservices-based applications, very large-scale applications that were highly resilient. The early focus really wasn't on what a lot of enterprises were wanting to do with cloud early on, which was certainly take advantage of those innovations, but also get access to other attributes of cloud, including running workloads they had already. And so there's been a shift in Google Cloud with the introduction of new services, new capabilities over the last many years, with an increasing focus on enterprise computing and in particular industry solutions. So high performance computing is a really important segment of both enterprise computing in the commercial sector, the government, nonprofits, institutions and research community. And I think Google recognized that there was specific solution patterns, specific terminology, capabilities, that the pieces were there, but really to engage the high performance computing community and market, you needed to bring those pieces together and talk about them in language that was familiar. So that's really why I came to Google, is to help accelerate that and add more HPC background to Google's offering.
And what have you been up to for the first 12 months then, Bill?
Well, a lot of what I was just talking about. So, one of the reasons I came to Google is I looked at the innovation, the capabilities, the investment, and it was very clear that Google was investing in cloud to be a major player and to win. At the same time, I could see ingredients that I felt were really capable. Compute, network, storage, which are foundational, were there and really high performance, great usability. But I didn't see Google really talking about them in a way that would come together into, I don't want to call it a solution necessarily, but an HPC user is oftentimes an engineer or a scientist, or an HPC administrator is thinking in terms of the infrastructure they have on site and the tools they're familiar using. So just knowing that, when you look at cloud and you see all these ingredients, you see all these tools, how do you translate it into what it is you want and what you need? So a lot of what the time I've been spending is starting to pull that narrative together and starting to put the pieces together in a way that we can talk to our customers, build up partnerships, work with the key ISVs, and really work more at that solution level. The other thing I've been working on a lot is really just reaching out inside Google. It's obviously a very large company and a very diverse company. And so finding other kindred spirits who are interested in working on HPC, already working on it, working on related fields such as AI and scientific computing, academic computing, research computing, talking to folks in the various industry verticals such as financial services, manufacturing, life sciences, and finding those connections where we can bring a lot of the things that Google is already great at and having a lot of success with in cloud, and bringing HPC into those conversations.
And that's something I want to pick up on as well, the different verticals and industries that you're talking about, Bill. Are there any specific early adopters, would you say, of HPC in the cloud in terms of industries?
Sure, there certainly are. And I think a lot of it comes back to, you can turn it around and say, what are the inhibitors of adopting cloud? And one of the early inhibitors of adopting cloud was trust and security. So as you can imagine, highly regulated industries have been a little bit slower to adopt cloud, or at least portions of their workload that were highly regulated are slower. Ones who are less regulated have been very quick to adopt cloud. Another dimension that was a barrier is that early cloud offerings really were built around these microservice-based architectures and really not geared for HPC workloads, in particular the ones that are tightly coupled using MPI, large-scale modeling and simulation. So as those capabilities have grown, we're seeing more of the tightly coupled workloads, such as a good example would be computational fluid dynamics, weather forecasting, climate modeling. But the early work was not so much, say, drug development, but maybe more drug discovery and genomics, which were embarrassingly parallel or pleasingly parallel, as some people say, in throughput-oriented workloads. So life sciences has certainly been a big adopter of cloud, again, on the genomics side, but growing into drug development. Manufacturing for things like design space exploration and optimization, and some of the smaller scale mechanical modeling and also car crash simulation. Another field is certainly financial services, who has a lot of, again, throughput-oriented computing, but also some tightly coupled. And energy has been another area where we're seeing a lot of adoption in terms of industry.
Okay. So obviously pretty widespread then. Are there any specific projects? I've seen things in the news about Google's HPC work within COVID-19 vaccine development. So if we picked apart maybe life sciences as one sector, can you tell us about some projects you're involved in there, Bill?
Sure. I actually joined during COVID, which was kind of interesting, right? To move to sit at the same desk and change from my prior job to come and work at Google and really only meet my coworkers virtually for many months. And a lot of this, COVID was quite underway, which means the high performance computing and cloud communities had already come together along with the research community and initiated a number of things to go attack the problem. And one of the ones that Google was involved with deeply, I didn't personally drive it, but I was really fascinated with, was a collaboration with Harvard Medical School. So in this case, we were very early in the pandemic. The vaccines take years to develop, right? What's actually happened has been remarkable, but nobody knew that at the time. And so there was a big focus on therapeutics. How are we going to treat the people who are sick? And the Harvard Medical School researchers had developed a tool called Virtual Flow. And what Virtual Flow does is it can access a database of billions of chemical compounds and actually send them through in a throughput-oriented way to do certain docking calculations and other types of calculations to understand, is this a chemical that is going to interact with in a productive way, targeting like 16 different proteins that they'd identified and active sites in the COVID virus. And so they were able to spin up many hundreds of thousands of virtual machines and CPUs and consume about 100 million CPU hours over the course of a few weeks. The result was they were able to identify out of this vast database of billions upon billions of chemical candidates, just a couple thousand that looked like they were worth studying at that next level for drug development. So it's this immense acceleration. And one of the interesting things that they told me is while they have an on-premise system that they could have had access to, quite capable system, to do this scale of work, they would have had to run for they said over a century to get the same results. And of course, a century later, the therapeutics aren't going to do us any good. So I think that's a great example of a place where cloud can complement an already capable on-premise system and respond to an urgent event. And we've seen other examples of this, such as emergency responses to things like the Boston Marathon bombing, or some work that Clemson University did with Google in terms of emergency evacuation planning, where again, accessing millions of CPUs quickly is critical to getting the answer you need to respond in a certain event.
I mean, the use cases are endless. Something that came up on Altair's conference last week, Bill, was digital twin and autonomous driving, and how the sort of convergence between HPC, AI, the cloud are so critical to those use cases as well. Do you work in those application areas?
I do some, and I have. I think maybe autonomous driving, we'll take that one first. It's really interesting, right? Because autonomous driving is leaning heavily on the innovations over the last several years in AI. But that is a data-intensive, right? A very, very data-intensive problem to train. And so one of the questions is, where does the data come from? And certainly there's lots and lots of vehicles out there collecting real-world data, but it's going to take a long time to drive all the world's roads, and not just drive all the world's roads, but actually see all the things that can happen. So a lot of the things that are used in massive multiplayer gaming, for example, right, to bring lots of people online, have them interact in unpredictable ways, see each other, can actually be used to generate synthetic data. And that synthetic data, in many ways, that is a simulation, much like an HPC simulation where you're simulating the physical world. That, in turn, provides synthetic data, which can not only test these machine learning models, but also train them. The other side of that coin, of course, is training these models means accessing that data and doing the very hard computation. Well, machine learning is in many ways a high-performance computing application. It's doing dense linear algebra. It's doing very large-scale collectives. It's leaning on high-performance parallel file systems. It's doing a lot of message passing, right? And it's running tightly coupled at large scale. So except for the fact that the floating point formats that are used in machine learning differ from those used for, say, computational fluid dynamics, there's many, many parallels. So it's really exciting seeing how the techniques and the technologies that have been developed over the last decades to serve scientific and engineering computing are now also helping fuel innovations like autonomous driving. The other thing you asked about was digital twins. I think I have less to say about that, but there's a lot obviously underway in the world of smart factories and machinery, trains, just trying to understand everything from the control systems all the way down to the way the physical objects that are being modeled are going to behave, the way they're going to wear, the predictive maintenance that you should be doing. And so there's a really nice intersection between the methods of engineering computing, high-performance computing, and material modeling, mechanical modeling, that's really plays a critical role in getting an accurate digital twin as well.
So clearly unbelievable potential there, Bill. Of course, though, it's not just about the cloud. A lot of companies have still made a lot of heavy investments with their on-premise clusters and systems. Can you talk to us from a market perspective? What is the embrace of the cloud? Where is most of the investment going today?
Sure. I guess one of the first things I'll say is that on-premise systems are not going away anytime soon. And in fact, Google is pretty clear on our stance that we see a future that's hybrid cloud and multi-cloud. And what we mean is when you're using public cloud, it's not just Google. And when you're using it doesn't mean you're not using on-premise systems. Now, in the world of Kubernetes and so on, there's a lot of folks who are looking at common control planes. But in the world of high-performance computing, hybrid oftentimes means being able to build a system on-premise that's right-sized, that you can keep busy all the time with some of your hardest problems. What that does is it ensures that you're getting the great economics of a system that you own and operate. Cloud complements that, bringing additional capacity, because no matter what size system you own, the demand that you're trying to serve is oftentimes and almost always variable due to seasonality, due to starting and ending projects, due to urgent events, maybe a safety incident relating to a product of yours where you need to disrupt future product development in order to investigate something that happened in the field. That's terrible for a company. So being able to access the capacity of cloud is really empowering in terms of keeping productive the most valuable investment of any company, which is its people. But there's other reasons cloud is interesting. It's access to new technologies, the ability to try things out without having to buy them or use them periodically, being able to access new technologies and decide how much you want to buy and when, and also creating R&D sandboxes so that you don't disrupt production computing and maybe enable people in new ways through collaborations around a powerful worldwide network, or perhaps enabling people by having access to services that would be difficult to build on their own, like analytics or large-scale AI. So cloud is a really nice complement to on-prem. And I think if you look in terms of the size of the market and the growth, some of the best data that we see out there is analysis from Hyperion, and Intersect 360 also does a lot of work in this area. And I think the consensus view is that the high-performance computing market, in terms of infrastructure, servers and storage, is somewhere on the order of maybe $19 billion a year of annual spending, which is a significant fraction of the worldwide IT infrastructure spend. But cloud on top of that is somewhere around $5.5 billion and expected to grow to $9 billion over the next 4 years, or 3 to 4 years, actually. So it's on a really steep trajectory. And HPC in the cloud seems to be growing 2 times or more faster than on-premise. So really strong uptake.
Wow. And as you said, there's sort of advantages to both options, of course, and it's not black and white. It's sort of hybrid deployment options. Can you talk, Bill, about how a company can embrace hybrid then, the technical challenges of this sort of hybrid setup?
Well, sure. I think one of the things that the folks who want to adopt cloud need to kind of recognize first is that cloud does seem sort of confusing if you just approach it, log into a console and you see all these concepts. And it's not familiar in the way that if you had a truck back up to your dock and it dropped off some servers and some networking cables and some storage, you're like, I know how to put those together. Well, in the cloud, you put things together, you order them, you put them together through API calls. So one of the things that we've really focused on is working with partners to create the tooling and help them enhance the existing tooling so that it understands cloud to lift that burden. So, great example, the work that we have underway with Altair. PBS Pro understands Google Cloud and its interfaces. So users today, especially in the industrial segment, very heavy users of PBS and also Grid Engine, don't need to learn cloud. They simply need to put their credentials in and say, what is it they want? Do I want a cluster of a certain size? Do I want this cluster to be able to scale to a certain size and scale back down to 0? And all of that complexity in the interfacing with the cloud is done by the tooling. If you want to do it on your own, then there's other tools out there as well, including tools that Google's developing. So the first step, of course, is creating that familiar, compatible environment in the cloud and saying, oh, this is really no different than if I own my own data center. I can log into these nodes, I can control security, I can access file store, I can run the same workloads I run today. So compatibility, ease of deployment, I think are really foundational. After that, hybrid strategy really comes down to two big challenges, which is one is policy. What do you want to run in the cloud versus run on-prem? You probably always want to keep your on-premise system busy because you've already paid for it. So that has to feed into your policy decisions about job placement. And fortunately, again, tools like PBS Pro make that relatively easy for people, in conjunction with Altair Control, to express policy and then have the engine implement your intent. The other big challenge, and this is a tough one, is data movement. Everybody really wants the flexibility of being able to make a very late decision and say, this workload could run on-premise or in the cloud, and I want to make a decision at the end because, again, I want to keep my on-premise system busy. I've already paid for it. But there is a cost and a complexity of data movement. So, again, understanding what data is moving or needs to move and moving it in time and seeing if it makes sense to run that workload, if it's maybe has too much data gravity. These are all considerations in a hybrid deployment. But fortunately, this is an area, again, where quite a few companies are really starting to build tools to support users.
Okay. And then, Bill, in terms of the wider challenges with the embrace of cloud, you mentioned 2 earlier in security and trust. Are there other big ones? Are there any that keep you up at night, Bill?
Other challenges, let me think. I think it's been demonstrated pretty well, and nobody knows what the right answer is here, but I think it's been demonstrated pretty well that the cloud providers have a good approach to security and a novel approach to security. Google in particular was a pioneer in this notion of a zero trust architecture. So you build up from trusting nothing. So everything has to be turned on. There's nothing that you need to turn off. And that type of approach has made it possible, for Google and other cloud providers to secure their environments for their own services. And we all have an excellent track record on that front. There's a comfort around security of knowing that, your servers are sitting somewhere and they're sitting in a building and you have perimeter security and you have a number of other protections in place. But we've also seen quite a few data breaches, right? When they can come from the supply chain, they can come from zip drives, that are dropped in the parking lot that people plug in to see who does this belong to. It was a coworker. So there's a lot of attack surfaces, and cloud providers and Google in particular have put a lot of energy into this. So I think the comfort with security is coming around and has dramatically changed. I think the other concern is cost. If we make it easy, I've heard customers say, I made it easy. The demand for HPC is insatiable. And the first thing they did is they went crazy with all this extra capacity, and I got a big bill and I had to shut things down until I could understand my spending. So again, this is a place where cost controls and going in, knowing what you want is really important. Cloud providers, and Google included, are looking at ways to make it possible for you to spend more when you need something that is more valuable, which is, give me 1 million cores right now. I need them for a business critical purpose. But there are other situations where you say, I could use 1 million cores over the weekend. It's not business critical. I just need to push a problem along. And in that case, you could use something like our spot instances, which are up to 90% off, right? So a lot of this is about getting the right economic models and then mapping them back to the workloads. And in some cases, creating tooling that didn't need to exist before to understand available capacity and to tolerate disruptions and restart jobs so that you can get your work done most economically. And that's, again, a place where a lot of folks are maybe having to think about new problems and invent new tooling so that this can be automated.
Perfect answer, Bill. Another thing I hear a lot in the market as regards the challenge is the sort of green element of some of these massive computing clusters and very high performance architectures. What's your response to those concerns?
Well, I think not everybody, but I think lots of people are concerned about sustainability for sure. And, Google has a big commitment around sustainability. But before I talk about some of the things that Google's done on that front, I just guess I'd make one point, which is I've said several times that, once you've paid for something, it's important to keep it busy. But one of the big drivers for cloud in the first place was that IT organizations had to build for peak capacity and spikes. And it was very expensive to do so because the average utilization was quite low. So think about a retailer who maybe needs to build for the Black Friday and the holiday season, that peak for their website. That meant that a lot of the servers were probably quite quiet, in the February, March, April period. And so when you build a data center and you turn these servers on, if you're not keeping them busy, the environmental footprint of that is quite high if you compare the energy and the carbon footprint to the actual useful work that's being done. So the early appeal of cloud was, how do we consolidate more users and take advantage of laws of large numbers, which is the average utilization can be higher when many people are sharing the same infrastructure. So part of the approach to sustainability is driving up high utilization so that the carbon footprint is, I'll say, amortized over more useful work. The other part is building the most efficient data centers, and that's another thing that you can do at scale. So as an example, Google builds very large-scale data centers, but they also have some of the best PUE, which is the measure of data center efficiency in the world. So they're bigger, but they're also more efficient, higher utilization. So their net carbon footprint for the work would be lower. But then Google's gone beyond that. Google, I think in 2007, was the first company to go carbon neutral. So when you're running in a Google data center, starting in 2007, which is I think even before cloud was available from Google, the operations were already carbon neutral by buying high quality carbon credits. 10 years later, 2017, Google transitioned to 100% renewables for its worldwide operations, all the electricity consumption, by buying renewable credits and direct renewable power. And then in 2020, Google took it a step farther by actually going back and buying high-quality carbon credits to erase the entire carbon legacy of the company back to its founding. Looking forward into the next decade, I think Google is the most aggressive in its commitment to try and become entirely carbon-free energy by 2030. So big commitment to sustainability and running a green cloud.
So it seems like we're ticking off every challenge box by box, Bill, and I think the cloud is passing in flying colours here. So it does seem like the resistance is out of pure inertia sometimes, and oftentimes it's sort of a mindset shift that we need to look for. How do we start that journey, I guess, with people?
I think part of it is social and cultural, but part of it is actually just a question of having time. Right, having time to go in and learn about the things that you want to do. And we all struggle with this, right? We don't get to find the time to do all the things we'd like to do, even if we know they're valuable. Some of the early, I'll say, cultural, social resistance that I saw was a lot of folks early in the days of cloud, at least in the high-performance computing community, felt there was nothing new there. They said, we've been doing shared systems forever. We're already efficient. We're already running almost 100% utilization. And I think what was different is, while it's definitely a shared model and has many of the same attributes, the generality of cloud is much greater, and the ability to customize the environments and serve a wider range of workloads than HPC has been really interesting, and that's what's driven the growth. And of course, once it achieved a scale that eclipsed any HPC installation, the possibilities for these kind of things of, could I get 1 million cores and solve a problem in a few hours? And the answer is yes. That opens up new possibilities. So I think the early days of feeling that cloud either was not new or potentially was a threat, that we wouldn't need our on-prem systems anymore, therefore we wouldn't need administrators, those are mostly gone. I think people understand now that cloud is an option, and it can actually make them more valuable in their job and more valuable to their users. We still need HPC experts to provide services. Cloud is just another way to get access to the infrastructure and services. The other side of that is the time. And I mentioned this before, which is, cloud could be difficult to approach. And I like to think in terms of, you see something like a kid's play structure in your neighbor's yard, and you say, I'd really like one of those for my kid. And it takes a while. And when you finally get the time, you go to a home improvement store, you look around, and you see all these ingredients and sheets of plywood and lumber and screws and tools. And you're like, where do I start? And it gets easier when somebody provides you with a recipe. You can go buy that toolkit that has the hardware you need, tells you exactly what you need to buy, what are your cuts. And then we're able to go and get what we want. So I think a lot of what's happening now is folks didn't have the time to go and create the tooling. We've talked about all those challenges, but as more tooling comes from the community, more experience is out there, companies like Altair are investing in making it easier. I think we'll be able to cross over that, and it won't be such a burden for folks to explore and ultimately adopt cloud and add it to their HPC offerings.
And what advantages will we see off that then, Bill? As you said, everything's being made easier. I think we're going to have more and more people. The topic of democratization is here in the cloud as much as it is in data. What advantages would we see off that?
Oh, there's a lot of advantages. I think one of the early challenges was that the scientists, the engineers, the researchers, and other knowledge workers who really needed access to HPC had to come to a center, and in many ways, just for efficiency of operations, they had to adapt their workload and their way of working to the offering. So if you went to a national supercomputing center, they would tell you what machines they had, what operating systems they ran, and you really didn't have much say in that as a researcher. The alternative wasn't great either, right? Which is I can go build and manage my own systems, but I really want to be a scientist, for example. Or cloud opens up a new possibility. I can go self-serve, but I'm still learning, in a sense, to be an administrator. So I think what's happening is, as providers of high-performance computing services embrace cloud and add that to their portfolio, we get the best of both worlds. Scientists and engineers and other users can still use the on-premise systems, but they can have access to tailored environments. They can create collaborative environments that span many work groups around the world and are not constrained by the choices of hardware or software that any one team made, sitting wherever their supercomputing center is. So there really is a true democratization. And I think we're going to see people moving from talking about infrastructure and the technology and more about the environments. I need to create a job and submit it with Slurm. I need to submit it with PBS Pro, Grid Engine, LSF, whatever you're using. I want to interface with a Jupyter notebook. I want to use Julia. I want to use Python, and really not so much about what is the underlying hardware or how did it get built. And that's going to open up tremendous opportunities for accelerated research.
And I think this brings me nicely onto this whole topic of Future Says. I mean, it's the title of this series, and I think you're sort of leaning into this. This is all happening right now. This is all happening in the days and weeks and months ahead. Where do we sit in 5 or 10 years' time, Bill? What are we talking about then?
Well, I think what I was just touching on, which is people are going to think less about the infrastructure and the how, and is it the what? And what is it I want to do, and what are the outcomes that I'm getting? And just as today we don't really talk about electricity and power generation, we take for granted that if we buy something that we'll be able to go and plug it into the wall, it becomes a utility. And over the last 10, 15 years, people have talked about grid computing. They've talked about utility computing. Cloud is really starting to make that a possibility, but it's not just the infrastructure from cloud. It's all of the utilities, all of the tooling, all of the ecosystem that actually makes it accessible. And then people really don't have to. I think we may even see that people don't talk about high performance computing per se. They just talk about the work they're trying to get done. They only need to talk about high performance computing today because it's a place you go. And in the future, you'll just say, these are the outcomes and this is the research I'm doing, and computing will become a commodity. I think that's pretty exciting.
And from a personal or a corporate perspective, Bill, are there other emerging technologies that you're keeping track of at the moment?
Yeah, I mean, certainly longer term quantum computing is very interesting, right? I think it's gone through the hype cycle where some people thought it was going to replace conventional computing. It won't. But we're actually starting to see algorithms developed and real problems where a quantum computer could complement a traditional high performance computing environment and perhaps cull a space and lead to a solution faster by accelerating optimization. There's some promising early results, variational methods there where there's an interplay between a traditional computer and a quantum computer. And there's so much investment happening both at an industrial level, commercial level, and also at a national level and around the world, and many, many countries, that I think we're going to see an acceleration of this. So that's going to be pretty exciting to see quantum. And in particular, I think quantum, like high-performance computing centers and like cloud, is something that's going to benefit from being centralized as a shared resource. And so I'm expecting that we're going to see quantum systems deployed alongside HPC centers, alongside clouds, in a way that people can share access and tie them into other resources and services.
It's so exciting. For people watching, Bill, that have learned a lot, I'm sure they've taken a lot of notes. I'm sure they want to join this journey towards the convergence of HPC, the cloud, AI, other emerging technologies. Do you have any last advice to them to how to get started on this journey?
Oh, great question. Well, they can certainly give us a call and we'd be happy to talk about any of these things. But yeah, I think these problems are hard. AI, we're still very much at the beginning of the journey. I think cloud is still very early, believe it or not. But you have to start your journey by having a conversation. And one of the things that I think we're trying to do, and it's really resonating with our customers, is not start with all the new different things, but how do we help you do the things that you already know are valuable and want to do, and do that in cloud, and then what new possibilities does that open up? So I think just taking that first step, with whether it's an AI service or HPC in the cloud, and get you on that path, and you can take it at your own pace, but get started. Yeah,
start small, start early, and scale fast, use case by use case.
Absolutely,
we agree fully with you there, Bill. Bill, it's been a real pleasure. That time absolutely flew by. We'll be putting some show notes to all the different use cases and discussion points you mentioned. And we really appreciate your time and hope to see you in person and online again very soon.
Well, thank you very much for having me, Sean.
Thanks for watching. Now, next up on altair.com/future says will be Sahara Sadi, AI research lead at King. She'll be speaking about all things AI ops and gaming content automation. Hope to see you there.